It's a fun family day before a family holiday.
Okay, so we're going to be talking about binomials containing radicals. So yesterday we added and subtracted. Today we're going to multiply, and binomial means it has how many terms? 2 terms. And when we do it with just like 2x plus 7 times 3x minus 1, we use this method, we use this acronyms. Anybody know it? FOIL, right? Okay. So we're going to use FOIL to multiply our 2 binomials. So example number 1, we're going to take 4 plus the square root of 7, and we're going to multiply it times 3 plus 2 rad 7. And if you like to use the box, you can definitely use the box on these. I'm just going to use FOIL. So I'm going to do first, outside, inside, last. All right. So F is for first. 4 times 3 is 12. O is for outside. I have 4 times 2 rad 7. So that becomes 8 rad 7. I is for inside. So I have rad 7 times 3, which is 3 rad 7. L is for last, so I have rad 7 times 2 rad 7, which is 2 rad 49. Clearly we have some simplifying we can do, right? It's radical. And we have some like terms. Sometimes, like yesterday you learned you might have to simplify first, but these are both what we call like terms, and we can combine them because they both have the same number under the radical. So we're going to call that 11 square roots of 7. Bring down this 12 for now. And then let's simplify this guy over here. What's the square root of 49? 7. So this is really 2 times 7, which is 14. Okay? We are almost done, but I see another pair of like terms, right? So 12 plus 14 is 26. And then 11 square roots of 7. Standard form when you're writing your binomial is to put the number first and then the radical second. Is it wrong if you put the radical first? No, but it's just not polite. I don't know. Okay? Any questions on example number 1 there? All right, example number 2, if we have 2 square root of 3 minus the square root of 6, and then we have it squared, right? There is a pattern that you can follow, but I think it's just as easy to FOIL. But if you have the pattern memorized, then go for it. But I'm going to show it using FOIL. So I'm going to do 2 square roots of 3 minus square root of 6 times 2 square root of 3 minus the square root of 6. It just helps me visually to write it out. So F is first. 2 rad 3 times 2 rad 3 is 4 rad 9. Outside. 2 rad 3 times negative rad 6 is negative 2 square roots of 18. Inside, I is for inside, so negative rad 6 times 2 rad 3 is negative 2 square roots of 18. So this is part of the pattern, that this term and this term are the same, okay? There is a shortcut, but you can choose to do it or not do it. All right, L is for last. Negative rad 6 times negative rad 6 is plus the square root of 36. Those birds are like going crazy today. Okay. So let's simplify as much as we can, right? We've got square root of 9. Square root of 9 is 3. 3 times 4 is 12. Okay. Then we've got this term and this term, which are like terms. So I'm going to combine them to get negative 4 square roots of 18. And then over here, I've got the square root of 36, which is 6. All right. So let's simplify even more. Now, we combined these negative 2 square roots of 18, but can we simplify the square root of 18 any? Yes. Does it have a perfect square factor?
Yes.
Yes. What's the perfect square factor of 18?
Yes.
9, right? So I could rewrite that as negative square root of 9, or say negative 4 square root of 9 times the square root of 2, right? And the square root of 9 is 3 times negative 4 is negative 12 square roots of 2. And then I've got this 12 and plus the 6 over here, so 12 plus 6 I think is 18. Did I skip too many steps? Okay. Any questions on example number 2? All right, one more. All right, example number 3, we're going to take 3 plus the square root of 5 and divide it by 3 minus the square root of 5. So why is this included in this section? Right? Because you can't have what in the denominator? The radical, okay? So you're going to need to multiply this by the opposite of this. So you're going to say 3 plus the square root of 5 and 3 plus the square root of 5. So guess what you have to do twice? Foil twice. You have to foil the numerators. You have to foil the denominators. I wrote foil. Okay, because this is your binomial times your binomial, and this is your binomial times your binomial. All right, so let's do the numerators first. F is for first. 3 times 3 is 9. O is for outside. 3 times the square root of 5 is plus 3 square root of 5. I is for inside. Same thing, another 3 square root of 5. And then L is for last, so you have the square root of 5 times the square root of 5, which is the square root of 25. Okay, that's the FOIL of the numerator. Now let's FOIL the denominator. So first, 3 times 3 is 9. Outside, 3 times rad 5 is plus 3 rad 5. Inside, negative 5 times rad, or sorry, negative rad 5 times 3 is negative 3 rad 5. You can see that these two are opposites, right? And then L is for last. So negative rad 5 times positive rad 5 is minus the square root of 25. Okay, now let's simplify. So up here in the numerator, let's do that first. We have a square root of 25, which we know is what? 5. It's going to be that way in the denominator too, right? So we've got a 9 and a 5. Those combine to get 14. And then we've got 2 of these 3 rad 5s. So that's 6 of them. Okay, there's our numerator. Now let's look at the denominator. We've got a 9 minus a 5, which is 4. We are really close to being done, and most of the time you would be done at this point. But what do you notice? These are all even, right? So I'm going to factor out a 2 up here, and that gets me 7 plus 3 rad 5 over 4. So the 2 and the 4 can reduce to what? 1/2. So this is 7 plus 3 rad 5 over 2. All right. Any questions on example 3 there?